Yeah. Hi, hello everyone. This is Shanmugaraj. Welcome to my channel. One of the aims of this channel is to build a global knowledge sharing platform in the domains of leadership, agile, and project management. You can join me and help me with that either by subscribing to this channel or sharing my videos to our friends, right? So, having said that, let us get into today's topic. We are currently discussing some of the leadership ideas from MID Sloan School of Management. Today's topic is what's next for Gen AI. So, what's next for generative AI, household chores, and more? This particular article has been published in March 7th, right? So, two AI practitioners explain how large X models that turn text into actions may ultimately allow generative AI to water plants and peel potatoes. In a recent study by researchers from the University of Oxford, artificial intelligence experts predicted that up to 40% of household chores, primarily housework like cooking, cleaning, and doing laundry, will be automated within next 10 years. Right? So, what technological developments are necessary for everyday tasks to be transitioned over to AI? So, this brings the concept of large X models. The key idea behind generative AI is the use of foundation models. We have coined a phrase for these types of foundation models, which is large X models or LXMs, where X is the training data category required to give the AI general purpose capabilities in a specific space. For language models, X is a text data. For machine models, X is a machine data. And for action models, X is a human action data. So the opportunities for LXMs are endless, including existing chat models, potential physical models assisting with household chores, and heavier lifts such as industrial manufacturing. A well known example of a foundation model, the large language model, is trained on a massive amount of text data and can generate coherent and fluent text for various applications. Similarly, a large sensor model is trained on swaths of sensor, process, machine, even data across a large variety of machines, processes, product, and sensors. Large sensor models could be used to monitor, diagnose, and optimize industrial machines and processes and generate new designs and configurations. Along the same lines, a large behavioral model trained on data derived from videos of humans doing physical tasks could be used to teach robots how to perform various chores and activities such as watering plants and peeling potatoes. The promise of LXMs. Though traditional AI has been applied to reduce machine failures and manufacturing defects and to improve manufacturing efficiency in terms of raw materials and energy consumption, progress so far has been challenging. LXMs will accelerate advancements in these areas. A large sensor model would not only be generally usable out of box but also easier for factory operators to use it if a natural language interface was added on top of it via an LLM, right? So right away, such a construct removes the friction points of data accuracy and adoption. Natural language driven zero downtime, zero defect factories with reduced energy consumption sound cool, right? So, but maybe all you are looking for help with is making coffee or other domestic tasks. Toyota Research Institute is using diffusion, right? Diffusion is a generative AI technique used for popular text to image applications. They're using diffusion to teach robots to peel vegetables, among many other tasks that took months to teach machines using programming, now take an afternoon using generative AI. The founder of AI robotics company Figure, Brett Adhoc, thinks that we'll have access to those benefits by 2030. Let us enter general purpose robots powered by LXMs. So, machine automation has long been a driver for productivity gains in the major areas of physical work, like agriculture, manufacturing, construction, logistics, hospitality, and healthcare. Industrial robots are another driver for productivity in physical works. Whereas those have traditionally been programmed for specific tasks, smart and autonomous robots have emerged primarily in past decade with prevalent use cases in logistics. In the past 2 years, there is a wave of general purpose humanoid robots such as those from Agility, Boston Dynamics, Figure, Prosper, Sanctuary, and Tesla. Prosper claims that it is making a robot called Alfie, a robotic helper for home or office. Alfie can clean, organize your things, and take care of small chores such as watering plants. So, what's the path forward? These kinds of activities are becoming more conceivable by the day. New research presented by the robotics team at DeepMind, Google's AI lab, describes how the use of powerful LLMs covering automation, reaction times, and motion tracking allowed their robots to learn about and understand complex tasks. To show the potential of these findings, they even produced models of robots opening and closing the drawers, removing the soda cans from the countertops, and moving items around. So overall, the technological possibilities with generative AI are awe-inspiring. So while we are still in early innings with LLMs, companies have been and continue to develop models such as Toyota's a large behavioral model, Google's a general purpose RTX model, and Runway's general world models. With this, we come to the conclusion of this video. Hope you guys got a better understanding how generative AI is evolving from industrial automation to household automation, right? The emergence of LXMs and the path forward is to make sure that robots like humanoids, right, that can do the routine tasks like watering plants and peeling vegetables, right? I hope you guys like these kind of videos that helps you to become a better, better leader, right, in your career, right? With that, I'm signing off. See you next video.